Okay, so welcome to the terrestrial planets lecture. This will be the first of a two-part series. We're going to be focusing on the inner solar system. That is the planets closer to the sun with this lecture, and we'll be focusing on the gas giants, or the planets further from the sun, in the next version. So, as we know, gravity is what we have to thank for all of this being possible. And so we'll zoom in first on our central star. So the star of the solar system we know as the sun. This is a little bit of a review, but all stars get their energy from fusion. Remember, that is the combination of hydrogen fusing to form helium, and then eventually when the hydrogen runs out, helium will fuse with each other to form carbon. And in supernova, you end up with even heavier elements. So, quick sun vocabulary. You have the photosphere, which is actually the visible surface of the sun. Inside of the photosphere, where the fusion happens, is the chromosphere. And oddly enough, outside of the photosphere, above the surface, you have the corona of the sun. That ends up being much, much hotter than even the interior. That has something to do with magnetic waves. We won't really get into that, but it's a very interesting thing to know. So far, you don't have to copy anything onto your note cards just yet, but we are getting there shortly. First, the sun happens to be 870,000 miles in diameter, which, as you will find out, is insanely big when compared to the planets that orbit it. It is named after the god Helios in Greek, or Sol in Roman. Its day length, remember, the day length is how long it takes for the planet or star to actually rotate, not orbit, because the sun doesn't really orbit anything, it just exists. It rotates, however, every 25 Earth days. And because it doesn't orbit anything, it doesn't have a year. Obviously, it's hot, right? Fusion produces insane amounts of heat, so it's about 9,000 degrees Fahrenheit. Spacecrafts have orbited it and gotten quite close. In fact, we have several near it now. Its moons, the sun's moons, are in fact all of the planets that orbit it. That is the definition of a moon, something that orbits something else. It's not solid. These are the interesting facts of the sun. It kind of varies in shape, and it contains 99.8% of the entire solar system's mass, which is pretty neat. So far, don't have to copy anything down. We will now spend the rest of this lecture focusing on the rest of the terrestrial planets. So they are known as the inner planets. They're interchangeable terms. The inner planets are all of the terrestrial planets. So closest to the sun, you have Mercury. Following Mercury, Venus, Earth, and then Mars. So they're grouped together because, first of all, they orbit closer to the sun than the rest of the planets, and also they all are terrestrial. Terrestrial meaning of Earth. It is Earth-like, rocky. They have a rocky crust. They have a dense mantle. They also all contain cores, solid cores. We'll get into that in a moment. First, here is a brief picture of the orbits of the Earth. I will return to this near the end of the lecture, but the red orbit, you cannot see it, but that is Mercury. Venus after that, Earth, and then with a little bit more gap between Earth and its red planet Mars. So we will begin with Mercury. Mercury is the smallest of the four inner planets. Again, these are all terrestrial or Earth-like. So now we can begin taking notes. Diameter of Mercury, 3,000 miles across. It takes 59 Earth days for one Mercury to rotate. So where one Earth day, we take one rotation. Takes one rotation to have a day. It actually takes 59 days on Earth for Mercury to rotate once. However, its year is much, much shorter than Earth's. Earth, remember, is 365 days. This only takes 88 days to go all the way around the sun. That is why, or that is because, it is much, much closer to the sun than we are. Its weather, the temperature on Mercury varies drastically from a negative 200 degrees Fahrenheit all the way up to 800 degrees Fahrenheit. There's a question here. Why? The answer is that Mercury has very, very thin atmosphere, if any atmosphere at all. And so when its one side is facing the sun, it is getting a whole lot of heat from the sun. But the dark side doesn't have anything to retain that heat, and so it gets very, very cold because space is the only thing on the other side. So the part facing the sun, because it's so close to the sun, gets a lot of heat. The rest ends up being pretty darn cold. It is terrestrial. Again, we know that. 70% of it is metallic, consisting of calcium and magnesium. It doesn't have any moons. The gravity of the sun is too great for Mercury to exist with any moons orbiting it. Anything that would orbit Mercury would get sucked directly into the sun. Some interesting facts. There is some evidence of ice on its north pole. It looks a whole lot like our moon, as we found out when we were coloring it. It's kind of gray. There's hardly any atmosphere, and it is named after the god of travel. So we'll keep moving on. Here is a size comparison of Mercury and Earth. So it turns out that Mercury is not that much larger than our moon. And so these pictures are to scale. Pretty good comparison. So the next planet out from Mercury is Venus, and is Earth's sister planet because they actually are very, very close to each other, not only in the way they orbit around the sun, but they are similar in size, mass, as well as gravity. And so the size of Venus, it's 7,520 miles across. It takes about 243 days to rotate. Remember, Earth takes one rotation, 1 day. Venus, a whole lot longer to make one rotation. So 243 days in the time that it takes us to orbit, or in the time that it takes to rotate once. Its year length is 225 days long, so not that far off of Earth's orbit around the sun. It's a little bit shorter. That makes sense. It's a little bit closer. The weather on Venus, it ends up having a very thick and acidic atmosphere, and it is hot, generally around 872 degrees Fahrenheit. In fact, it is the hottest planet. It is terrestrial, but 96% of its atmosphere is carbon dioxide. So not something that you would want to comfortably live on. Has no moons. Again, it's a little bit too close to the sun. Some interesting facts about Venus are the fact that it has active volcanoes. It spins in the opposite direction of Earth. It is named after the goddess of love and beauty. And the Russian probe Venera actually landed on it. And we will be talking a little bit, hopefully, about Venera when we get into space exploration. So that is Venus. Here is a size comparison of Venus and Earth. Very similar in size, as we will find out, but yeah, almost identical, known as Earth's sister planet. Moving a little bit further away from the sun, so now we are at the third planet from the sun. We had Mercury, we had Venus, and now we are at our favorite planet, Earth. It's beautiful. Earth, diameter about 7,927 miles across. This now should all be reviewed. 1 day on Earth is the amount of time it takes for the Earth to rotate once. So 1 day is 1 day. It takes, again, 365 days to orbit the sun. That is how we measure a year. Ends up being actually 365 and a quarter days. If you happen to know a little bit about your trivia or what happens to a calendar, specifically in February every 4 years, that quarter day turns into 1 extra day, and every 4 years we experience what is called a leap year. And so that is what a leap year is due to, is the fact that 1 actual Earth year is actually 365 and a quarter days, and every 4 years you get an extra day. And so every 4 years we have a leap year. The weather on Earth, coldest it's ever been measured is a negative 120 degrees Fahrenheit. Very, very cold. And the hottest, about 130 degrees Fahrenheit. Very, very hot. But by and large, when compared to the other planets in the solar system, not too bad. Composition of Earth, it's obviously terrestrial. It's a rocky planet. But 60% of its crust is silica. And that is important when you want things like mountains and land. We have one moon. We know it as the moon or Luna. Some interesting facts about the Earth, and we could find many, many more than this, but we'll just focus on these for now. It's the only planet with a life. It's also the only planet that has liquid water, and it is the most dense planet in the solar system. That is a pretty neat fact. The densest planet. So then we come to the red planet, Mars. This is the fourth planet from the sun. It's known as the red planet. Ends up having kind of a rust color to it. Here are some facts about Mars. So it is 4,212 miles across. Each day on Mars is almost as long as a day on Earth. It is only 0.6 hours longer, so a little over 30 minutes longer. Its year, however, is much, much longer. So where the Earth takes 365 days to go around the sun, Mars, in Earth days, takes 687 days. So almost twice as much, twice as long. So you would be very, very young if you lived on Mars. Weather, it averages around negative 67 degrees, but it can get up to 68 degrees Fahrenheit. It's pretty desert-like. Similar, very similar to the composition of Earth. It is terrestrial, with about 60% of that crust being silica. It has two small moons, Phobos and Deimos. And a couple of interesting facts. Clearly used to have H2O, as it has polar ice caps. It has a very thin atmosphere of carbon dioxide. It is named after the god of war, that is Mars, and it is red, known as the red planet due to its iron oxide. It also contains the largest mountain in the solar system, and that is known as Olympus Mons. It is a volcano, and it ends up being about the size of Arizona. So here's a picture of the state of Arizona overlaid on top of this volcano, Olympus Mons. So as you can tell, it is a massive, massive mountain. Here's a size comparison between Mars and Earth. Mars, quite a bit smaller. It's much smaller than Venus, which would be Earth's sister-like planet, but still a decent size. And so, with that, we move into the asteroid belt. And in the next section of this lecture, we will talk about the gas giants, but first I kind of want to show you another version or another way of looking at the orbits of the terrestrial rocky planets. So here is actually a picture of the asteroid belt, and that is what actually separates the inner terrestrial planets from the outer gas giants. But I just want to take a moment and I'll pull up a program that shows the orbits of those four closest terrestrial planets. So here is an image of a program that we will play a little bit more with, but I have zoomed in just on the terrestrial planet. So I'll pause it just for a second. You have the sun, closest to the sun, Mercury, then Venus, then Earth, and then out here is Mars. So this is an accurate program. It actually shows not only the orbits, but also the rotations. So look at how quickly Earth is spinning. We can compare Earth rotating to about the same speed as Mars. Remember, their days are about the same, but they end up orbiting the sun at very different rates. So here's the Earth moving around. Remember, it takes Mars almost twice as long to get around the sun. So kind of a fun program. We'll look more at the gas giants later, but this is something I'll show you more in the future. These are the four terrestrial planets. We now will move on to